why do we need the voting protocols? That is the question. So basically, we are having the kind of a scenario, we are having the four sites S1, S2, S3 and S4. As we are seeing, we can see from the diagram, we see that all the four sites are connected to each other. Okay. Now, suppose what happens, somehow the messages to a particular site S4 does not reaches to the S4 file. So there is a kind of a message failure which is making this node S4 not usable. So basically, we want to do the work of site S4 from other sites. So that is S1, S2 and S3, and in the fault tolerance we say that we make a replica for the given sites. So we may have the data at the different site locations, so we can have a fault tolerance. But there are scenarios, one is this message failure, then another one is, suppose I say that a particular site S1 goes down. What will happen if a particular site S1 goes down? So this will lead to a scenario, again the same situation as we are having the failure of messages. So again, if this site S1 goes down, then the work should be completed on the basis of the three sites S2, S3 and S4. Similarly, what happens if some of the links between the two sites or two or three more sites get disconnected? So again, it's a kind of a network failure, but it is in the different way. Now, in the first case, there was a message failure, we were not getting the messages. In the second case, a particular process or a particular site goes down. In the third case, there is a network failure and it has partitioned my network. Now we can see that S1 and S2 are disconnected from S3 and S4. As we are seeing, say that in the fault tolerant network, there should be the availability of resources, and we can see that S1 and S2 or S3 and S4 are still available and they can perform the work. So this can be solved with the help of a protocols, that is what we call as a voting protocols. So what is it? It is a fault tolerant mechanism in which we have the cases of network partition, site failure or message losses, and we can give the performance without compromising the integrity of data. In voting mechanisms, a replica sites are generated, and each replica is assigned a number of votes. And we have to maintain the majority of votes that have to be collected from a process before it access the replica. So this is the scenario for the voting protocols. Now, there are two kinds of voting protocols. One is a static voting protocol, another one is a dynamic voting protocol. Now, initially, I am going to discuss the static voting protocol. So, what are the different things that we will require for a static voting protocols? The number one thing is that we have to get the replica to all the files that should be stored at the different sites. Then only we can go for the thing. Another important thing is that every file access requires appropriate locks. So this is the basic condition that if you are not providing the locks on the files, then there may be a scenario that you are going to write the file in the parallel to read. So that will make the inconsistency in the kind of a data. So there should be only one write and no read, or there may be a multiple reads and no write. So that is the case of scenario that we have to maintain. And every site will have a kind of a lock manager that will be performing this lock mechanism. And then every file will be associated with a version number. The version number will be stored at a stable location. Why we are going to say this is a stable location? Because that will help us to keep the record of how these updations were made. So we are assuming there is a kind of a location or a stable site where we can keep these things. Okay? Then each replica will be assigned a number of votes that again will be stored at the stable location. These votes will be helping us, these votes will be variable for the different sites and will be helping us to find which site is more reliable in comparison to which the other sites. So there will be a read and write permit on the basis of quorum. So there will be a kind of a voting whenever a site wants a particular resource, then there will be a kind of a voting that will be used by the and if there is a kind of condition that is quorum has been maintained, then only we can get the read or write permissions. Now, what is how this routing algorithm? How this voting algorithm is going to work? So there is a process. Suppose there is a kind of a site SI that issues a read or write request. So initially, what we are assuming that there is a kind of site. So that site SI will request a log to its local log manager. So starting, what will happen? That site will be starting. SI will issue a log request. When the log request is granted, I will send a vote request. So initially, what will happen? A local manager will be requested, and once the request has been approved by the local manager, then this request will be then the vote request will be sent to all the sites. Whenever a particular site J receives a vote request, it issues a log request to its local log manager. So this is the kind of scenario. So it is again going to its local and when it is granted, then it will return you a version number of the replica and the number of votes that it can give. So this is the number of the votes that it can provide. So it will be providing. Now SI will decide whether it has reached a quorum or not based upon the set of the rules. For suppose if the request that has been generated by SI was a read request, then it will be the sum of P case where K belongs to P. That is, I am going to sum all the number of votes that I have got, and we will get a VR. And if VR is greater than a threshold, that is what we are having as R, then we are going to say that a particular site is going to enter the getting the request to execute its task. Similarly, in the case of write request, what we are going to do, again we are going to sum up all the votes, but that will be in the element that is Q. जो भी set है, that is Q. And what we are going to do, we are going to make the maximum of the VNs. Now, what is the task of VN? VN was actually the version number. Okay. So here, what we are going to identify, we are going to identify which numbers are having the which votings are having the highest values. So that will be calculated by M, and based upon M, if what we are getting only the votes that are that only the votes of the current version replicas are counted and decide the right vote. So now there will be two scenarios. If the first scenario says that the number of votes to reach the quorums are not met. So in that case, what you will do, you have to release the logs on all the resources. So initially, so what the site I will be doing, the site I will be releasing the logs on a particular resource, its own resource manager, and it is also going to give their return their votes to the particular site. जिन्होंने vote दिया है, उनको भी वो बता देगा that you have to release the logs. Once the logs have been released, so what you are having, if there is a success in quorum, it checks whether the copy of a file, if VNI is equal to M, जब अगर मेरे पास grant हो गया है, मेरा successful collection of quorum हो गया, तो what I will do? I will first check the latest copy. The latest copy किससे मिलेगी? I will get it from version number. So once I got that thing, I will obtain the current. If it is not with me, I will get it. If it is with me, I will not obtain. So that is the scenario. And if the request is read, I read the local copy. If it is the right, then you have to update. I update the local copy and VN. So why it is updating VN? Because once you are going to write, that means you are going to update the file, and the new file is different from the previous one. So that's why we are going to update the version number. Once we have updated the version number, what the site I is going to do? The site I is going to update all the replicas with the version number VN. So because क्यों कर रहा है वो ऐसा? Because all the other sites that has given the vote in favor should get the updated copy, and after that it is going to release the log. All the sites receiving the updates perform the updates, and finally on receiving the release log they release the. So this is the scenario that is going to work. After this, so I am going to demonstrate this thing with the help of a diagram. step by step. So what is the first step? The first step was the let a process executes process executing at site 1 issues a read or write request. So what is there? The first step was that S1 will be going to send a lock request to RM. So that is the first thing. So सबसे पहले S1 ने क्या किया होगा? Lock request किसको send की होगी? RM को send की होगी, जो कि उसका local resource manager है. Once it gets, अब इसके बाद सिनेरियो ये होगा local. So what will happen? The local resource manager will grant its request. तो इसको local lock request grant हो गई. जब lock request grant हो जाएगी, तो what will be sending? It will be sending a vote request to all the other processes, that is S2 site, S3 site and S4. So that's why it has sent a message to all the sites. Once it has reached, once site 2 receives the vote request, it issues a lock. So automatically I am going to show this scenario for S2. The same scenario is working for S3 and same scenario is working for S4. So what will happen? Once S2 has received the request, it will send that lock request to its local resource manager. Local resource manager, so that it can get the things. So once it gets the thing, so what will happen? It will get a lock request granted, and once it has been granted, what will happen? It will again send the two things back to S1. That what is the version number of the file that has been stored over here, and second the number of ports that have been with the S2 to S1. The similar process will go from S3 to RM and S4 to RM. Now the site S1, after receiving the things, what it is going to have, this is a kind of scenario. It will be having S1 is having a local weight of 1, S2 will be having a local weight of 2, S3 is having a local weight of 1, and S4 is having a local weight of 4. So what is the scenario? First thing, if it is a write request, so we have given a threshold. Also, for write it is 1, and for read it is 1, and for write it is 5. So you have to take that weight कि यहाँ मतलब अगर मुझे write लेना है तो voting के कितने votes चाहिए थे? Only one vote is required, and if I am going to have more than that, I have to go for the write. Then I have required a weight of 5. An interesting thing to find over here is that the sum of all the weights, the 2 plus 1 plus 1 is equal to 5. Why it is equal to 5? I will be telling the reason for that also. So what is this? So here what you are going to do? You are going to sum VKs. So based upon that, if you are in the read request, if we do not have to get the quorum for the latest copies. In the case of write request, you have to get the first identify all the messages with the highest value, that is M, जो कि latest version number होना चाहिए, वो M में मिलेगा हमें, और फिर उस M के बाद हम आइडेंटिफाई करेंगे कि कौन से वोट्स मेरे फेवर में हैं, ठीक है, that are having the latest version number, उनके वोट्स को हम काउंट करेंगे, and based upon that we are going to decide the quorum. So that is the thing. So ये मेरे पास एक सिनेरियो है. अब क्या हुआ कि सपोज मैंने राइट रिक्वेस्ट भेजी थी और मेरे पास कहीं से लेटेस्ट वर्जन नहीं आया और somehow my quorum has not been reached. तो जब quorum reach नहीं होता है तो what you are going to do, S1 will be sending a request to release the resources. तो एक इसने अपने पास को अपने लोकल साइट को भेजा है. At the same time this request has been sent to site S2, S3 and S4. So in this way, what you have done? You have done this thing. And suppose what you have done here, what you have seen, अगर मेरे पास वर्जन की कॉपी, suppose what I am saying that my scenario is that I have been accepted for the quorum, but I do not have the latest copy. So what will happen? Here what I am saying, my version number is M-1, S1 is having the version number M-1, but S2 is having the latest version. So what we have to do? We have to request this file from site 2 to site 1. So that is the first thing. आप उसके बाद once you have got the file, what you can do, perform the operations on the local copy and send the increment the vn plus 1 and update to all the persons in queue. So this is the scenario that we are going to work. Now what is the rule for the vote assignment? So there are certain rules how these votes are assigned. So what is that rule? Basically what we are having the two operations, one is read and another one is write. So so they are R and W. So there should be a rule that is R plus W should be greater than a certain value, that is V, and the number of rights should be greater than half of the total majority persons. So that is V is what we call as a majority. Okay. So what you are doing, there are certain rules that you have to follow. We have to ensure that none of the obsolete copies are updated. So first operation is that there should be no copy जो पुराने versions की थी, आप केवल work करेंगे VM+1 जो latest copy है, previous versions को update नहीं होना चाहिए. So that is the first rule. Second interesting thing is that there is a subset of replicas whose total vote is equal to W. ऐसा जरूर होगा आपके सेट के अंदर कि जहाँ पे आपके पास एक रेप्लिका का जो सबसेट होगा जिसमें टोटल वेट्स का जो टोटल वोट्स होंगे उसका सम आएगा W. Again, there will be a non-intersection between the every read and write quorum. So there will be a certain scenario क्योंकि अगर आपने यहाँ पे W रखा है, so there should be a kind of at least one current copy of the रीडिंग कोरम. तो यहाँ पे ऐसा जरूर होना चाहिए कि जब भी आप रीड और राइट का कोरम मंगवा रहे हैं तो उसके अंदर एक कॉपी ऐसी जरूर होनी चाहिए जिसमें देयर विल बी वन कॉमन एलिमेंट, क्योंकि आपको ये पता है कि मेरे पास मुझे अपडेट्स करने हैं तो लेटेस्ट वाले को ही रीड करूंगा और लेटेस्ट वाले पे ही अपडेट करूंगा. राइट कोरम शुड बी हाई इनफ टू डिसअलाउ द सिमुलेशन साइमल्टेनियसली राइट ऑफ ऑन द टू डिस्टिंक्ट सेट्स ऑफ रेप्लिका. दिस इज द इंपॉर्टेंट थिंग कि अगर आप कभी राइट कर रहे हैं तो वो जो होना चाहिए that should be allow the simultaneous write on two distinct. ये प्रॉपर्टी जो है वो यहाँ से है, मैं दिखाता हूँ आपको. ये मैंने आपसे कहा था कि I am going to, so here what you are having, here you are having S1 is equal to 1, S2 is equal to 1, S3 is equal to 1 and S4 is equal to 2. So here what we have taken the weight as 5. So what happens if I am going to have the two right, तो क्या होगा, तो मेरे पास दो साइड्स अगर ऐसा कर रही हैं तो उनको टोटल वेट्स चाहिए होंगे 5. ठीक है, और साइमल्टेनियसली रीड और राइट ना हो जाए तो सबके पास क्या होने चाहिए थे, मैक्सिमम वेट कितना है मेरा यहाँ पे अगर देखूं तो सारे वोट्स को काउंट करूं तो व्हाट आई विल बी गेटिंग 2 + 1 इज इक्वल टू 5. यानी कि जब तक सारी साइड्स मेरी, अगर कोई भी साइड मेरे को सपोर्ट नहीं कर रही है, देन इट हैज सेंट हिज ओन रिक्वेस्ट, तो एक वेट कम हो जाएगा. सपोज मैं कहता हूं S1 ने रीड की रिक्वेस्ट कर रखी है तो एक S1 का जो वेट है वो कम हो गया होगा. वी विल बी हैविंग ओनली द वेट वोट्स ऑफ 4 कैंडिडेट. That means we cannot perform the write operation. तो write operation तभी होगा जब सारे जगह पे कहीं पे भी read operation नहीं होगा. So that is the case. वो important है. तो write high enough to disallow the simultaneous writes and the replica files. ठीक है. Now this is a scenario 1. अब यहाँ पे देखिए हमने क्या कर रखा है, यहाँ पे हमने एक scenario दिखाया. Here what we are having, S1 is having a vote value 1, S2 is having a vote value 1, S4 is having a vote value 1 and S3 is having a vote value 2. Since R1 and R1 is equal to 1 and W is equal to 5, so read will work because what is happening? Suppose I am saying if any one of the side is not is down. Suppose I am saying S1 is down. You can still work with S2, S3 and S4 votes. If S2 is down, even S2 even all the sides are going to be down. Then also because the read requires only one vote. So what will happen? S1 can perform the read operation. But what about the write? In the case of write, what will happen? We have been pushed in a scenario where all the votes are required. So here what we have done, we have written the write requires 5 votes and the 5 votes are only possible if we are having the votes from all the sides. But is this a current scenario? No. The reason behind this is that because we are saying that we are having the replicas of the files on the different sides, so what will happen, even though a particular side, say S3 is down, still S1 and S2 and S4 are available, so the files will be, latest files will be available based upon the S1, S2 and S3, S1, S2 and S4, so you can get the quorum. So next scenario is that, so how to do this thing, and there is an example for that. That is a scenario 2. Here what we have done, we are having the weights 1, votes 1, vote 1, vote 1 and vote 2. Now see what we have done, we have modified the value of W. Earlier it was 1 and 5, now it is read 3 and W 3. Now both read and write can work with the coordination of S1, S3 and S2 or S1, S2 and S3. So in this way they can work. So here what we have done, S1 and Sk. The K stands for 1, 2 and 4. So here these are the weights, so you can get the votes in the different combinations, and you can have the one side down also for the right operations. So this was an exact scenario. Now what is the drawback? This approach is basically a static approach. और जब हम बात करेंगे that approach is a static approach, that means why we are going to say it's static? Because majority, that is a quorum, and the number of votes assigned were decided in the beginning and will not be changed irrespective of the system state. So this was the scenario for the complete thing. So thank you. That's all for my presentation.